Okay, today I'm going to start the notes on section 2.4. They actually begin at page 46 of your journal. All right, page 46 of your journal. And remember, when we are doing multi-step inequalities, always look for a chance to add or subtract before you multiply or divide. Okay. All right, so let's start with page 46. And I think our first problem is 3x minus 2 is less than 10. Okay, so our first opportunity to add or subtract just occurs here with the negative 2. So we are going to actually start by adding 2 to both sides. This cancels out. I end up with 3x is less than 12. Now I have opportunity to divide both sides by 3, and x is less than 4. Okay, if I were to graph that on a number line, all right, this if you remember, this inequality here means that this is going to be a open circle. So we have an open circle at 4. This actually, then all the numbers are less than 4, so our arrow is going this way. This arrow actually extends all the way to negative infinity. So if I were going to put it in notation, soft bracket negative infinity, and it goes to 4, which is also soft bracket because 4 is not part of the solution, or it is a open circle. Right. Our next problem is 4a plus 8 is greater than or equal to 0. All right, and we are going to look for opportunities to add or subtract first. So I'm going to subtract 8 from both sides. This cancels out, leave me with 4a is greater than or equal to negative 8. I can divide both sides by 4. That cancels out. A is greater than or equal to negative 2. All right. Again, we've got a closed circle indicated by the greater than or equal to sign. Negative 2, negative 1, 0, negative 3. It is a closed circle at negative 2. And A are all the values that are greater than that. So greater than on the number line would be going this way. Once again, this will go all the way to positive infinity. So in notation, my 2 is included. So it's negative 2 in a hard bracket, and it goes all the way to positive infinity in a soft bracket. All right, number 3 says 2. Oh, I don't think I want to keep using this color. English. I like black a lot better. All right, so we got 2 plus b over negative 3 is less than or equal to 3. My first opportunity is going to be to subtract 2 from both sides. This cancels out, leave me with b over negative 3 less than or equal to 3 minus 2 is 1. Now to get this out of fraction mode, I'm just going to simply multiply both sides by negative 3. All right. Leave me with b on this side. 1 times negative 3 is negative 3. But what I don't want you to do is remember that there's a rule that anytime you multiply or divide by a negative number, you have to flip the inequality sign. Okay, so I have to flip the inequality sign. If I were putting this on a number line, negative 3, negative 2, negative 1, -4, -5. I have a closed circle at -3, and B is all the answers here. And this, of course, goes all the way to positive. I don't know. Seem to be having problems with my pen today. Goes all the way to positive infinity. All right. So if I were going to write that, I have a hard bracket at -3 because 3 is included, and it extends all the way to positive infinity. And that's going to be a soft bracket. Okay, number 4 says -c over 2 minus 6 is greater than -8. Add or subtraction first, so I'm going to add 6 to both sides. These two cancel out, bringing down the -c over 2 is greater than. The signs of difference, I find the difference between 8 and 6 is 2. The bigger number keeps the sign, -2. Okay. Now, all I can do is multiply both sides by -2 so that I can get rid of the negative and the 2 at the same time. These two cancel out, leaving me with c. -2 times -2 is a +4. And because I did this by -2, I have to flip the sign. Alright, so we could graph this. 4, 5, 6, 3, and 2. This is an open circle at 4. C is all the values less than 4, and these values will extend to -infinity. So in notation, I would have soft bracket, -infinity. It goes all the way to 4, which is also a soft bracket because 4 is not part of the solution. All right, so let's start at number 5. 8 is less than or equal to -4. And this time we have some distribution, +1. Let's not forget when we distribute, we have to distribute across both of the terms inside the parentheses. All right, so then I'm 8 is less than or equal to -4 times d is -4d. -4 times +1 is -4. And I'm going to add or subtract first, so I'm going to add 4 to both sides. 8 plus 4 is 12. Bring down the -4d, and these two cancel out. Now I'm going to divide both sides by -4 so that I can solve for d. These cancel out. Don't forget our rule about any time we divide by a negative number, we have to also flip our sign. So my sign flips, and I'm left with d is and -3 on this side. So -3 is greater than or equal to d. -3, -2, -1, -4, -5. This is a closed circle at -3, and all the values are greater than. Once again, this goes all the way to positive infinity. So if I'm going to do set notation, this is which is from left to right, this is a hard bracket because it is a closed circle. -3 is part of the solution that will extend all the way through infinity. All right, when we move to number 6, things get a little trickier because now we have variables on both sides of the equation. So we have 5 minus 2n is greater than 8 minus 4n. Okay. And this time you can add or subtract both sides. If you remember I think I gave the example, if we thought of this as a basketball court and this was center court, we decide whose baskets are here and whose baskets are here. So in this case, I'm going to say that I want all my ends to make their plays on this side and all of my constants or my numbers to make their plays over here. So I'm going to start by moving this player here. I'm going to add 4n to both sides. Alright, so I have 5. These signs are different. This becomes a positive 2. And it's greater than 8. Alright, the only player, if he wants to shoot, he has to be on the other side of the court. So I'm going to subtract 5 from both sides. This cancels out. And I have 2n is greater than, and 8 minus 5 is 3. My last step, to divide both sides by 2. This cancels out, leaving me with n is greater than 3 over 2. And that kind of doesn't clean that up a little bit. All right. And there we have it. All right. All right, so let's tackle number 7. 6h minus 18 is less than 6h plus 1. And you may look at this and say, wait a minute, I've got 2 6h's on both sides, and if I cancel out, then what? Well, let's find out. So I have 6h, let's subtract 6h from both sides. These two will cancel out. I'm left with negative 18 is less than positive 1. Is this a true statement? Yes, this is true. This is a true statement. Negative 18 is less than 1. So if that cancels out and what you're left with is a true statement, this is what we call all real numbers. All right, because no matter what number I put in there, it will satisfy that equation and the answer will be true. All right, so we call that all real numbers. Let's look at number 8. 3p plus 4 is greater than or equal to negative 4p plus 25. And once again, if you want to go with the analogy of, hey, I'm not sure what to move first, if this is center court, you can make a decision. Hey, I want all of my p's to shoot in this basket, and I want all my numbers to shoot over here. Now I know which side I'm going to start moving things around to. Totally up to you. It doesn't matter which side you move them. I happen to like my variables on the left side when I'm doing inequalities. So I'm going to add 4p to both sides. 7p plus 4 is greater than or equal to 25. This one cancels out. I'm going to subtract 4 from both sides. And I'm left with 7p is greater than or equal to 21. My final step is to divide both sides by 7. These cancel out, therefore p is greater than or equal to 3. Our next example is 7j minus 4j plus 6 is less than negative 2 plus 3j. All right, so you still want to look for the opportunity to add or subtract first. And what I can actually do is combine like terms, which would be adding or subtracting. So over here, I have 2 like terms. These 2 are like terms, so I'm going to combine those 2. 7j, positive 7 and a negative 4 leaves me with a 3j. So I have 3j plus 6 is less than negative 2 plus 3j. 3j. And once again, it's like, wait a minute, what happens if I cancel out the 3j's? All right, so what if we subtract 3j from both sides? We're left with, these two would cancel out. I am now left with 6 is less than -2. And perhaps in your Mrs. Martin voice you go, burn, burn. This is false. That is not true. Therefore, there is no solution. All right. So if the resulting is a inequality that is false, there is no solution to that inequality. All right. Let's try number 10. I'm going to go ahead and start with a fresh sheet of paper for this one. It's your favorite. It is fractions. I don't think I like writing in red. Let me get another color. All right, so let's go 12. And in parentheses, we have 1 over 4w plus 3 is less than or equal to 3, and inside parentheses w minus 4. So here's the fraction that no one likes. All right, here's the fraction that no one likes. And how do we do this? All right, so 12 times 1, this is essentially saying, what is 2? 12 times 1 over 4w plus 12 times 3. All right, I'm going to do it that way simply because I know that most people don't like dealing with the fractions. The second distribution is fairly easy. 3 times w is 3w, and 3 times -4 is -12. Okay. For some people, they'll immediately look at this perhaps and would have said, hey, this is the same as saying 12 divided by 4. Well, it is. 12 times 1 is 12, divided by 4 is 3. W plus 12 times 3 is 36, less than or equal to 3w minus 12. And once again, I'm left with a situation where what happens when I cancel out the 3 w's? And I'm left with 36 is less than or equal to -12. All right. And again, as Mrs. Martin would say, burn, burn. That's not true. Therefore, there is no solution.